Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Dear students, in this video we are going to solve a problem relating to relativity. Okay. We should know that relativity is of two types: special relativity and general relativity. Okay, Einstein's special theory of relativity and Einstein's general theory of relativity. Okay, however, these concepts will be dealt with in detail in our upcoming videos. For the time being, we are starting problems of quite introductory nature. Okay, we will come from soft or easier problems to hard problems gradually. Okay, anyhow, we come to statement of this problem. Okay, the proper lifetime of a certain particle is 100 nanosecond. Okay, we know that nano means 10 to power minus 9. Okay, micro means 10 raised to the power minus 6. Okay, similarly milli means 10 raised to the power minus 3. Anyhow, the proper lifetime of a certain particle is 100 nanosecond, and we have to find out three things. Okay, how long does it live in the laboratory if it moves at v equal to 0.960 c. Okay, so here c is not equal to speed of light, but it is less than speed of light. Okay, if we divide speed of light in 100 parts, then this speed is equal to about 96 parts of those 100 parts. Okay, so it is a very rough picture. Okay, how far does it travel in the laboratory during that time? Okay, what is the distance traveled in the laboratory according to an observer moving with the particle? Okay, part 3. As usual, first we will come towards helping tools. Okay, because dear students, you know that toolkit is very essential for our development of foundation of physics understanding. Okay, so this is the tool number 1. Okay, helping tools, tool number 1. What does tool number 1 say? Tool number 1 say that delta t is equal to delta t naught over under root 1 minus u square over c square. Okay, that is time dilation or time dilation. Okay, in relativity, time dilation, length contraction are basic concepts. Here, delta t is the time interval between same events measured in second frame of reference. Okay, not in first frame of reference, in second frame of reference. Okay, delta t is time interval between same events measured in second frame of reference. Okay, delta t naught is the proper time between two events measured in rest frame. Okay, this is rest frame, proper time between two events measured in rest frame, and while this is in second frame, second reference frame. 1 minus u square over c square, where c is the speed of light in vacuum and u is the speed of second frame with respect to first frame. Okay, speed of second frame relative to first frame or with respect to first frame. Okay, this the same tool can also be expressed in another slightly different mode as tool number 2, time dilation or time dilation. The dear students, here to the extent of delta t there is no difference. Okay, time interval between same events measured in second frame of reference, this is same thing. Okay, delta t naught proper time between two events measured in rest frame, this is also delta t naught is also same. However, here one new thing has been introduced, but this new thing is just a rearrangement of the first thing. Okay, Lorentz factor relating the two frames, gamma is a Lorentz factor relating the two frames. What is this gamma? This gamma is this 1 over 1 minus u square over c square. Okay, this thing can be written as delta t naught multiplied with 1 over under root 1 minus u square over c square. So here with the thing we are going to multiply can be renamed as Lorentz factor, which is denoted by gamma. Okay, so in the second tool we have shown the same expression. The only difference is that here in place of 1 over under root 1 minus u square over c square we have introduced a sign gamma, to which we have given the name Lorentz factor. Okay, Lorentz factor relating the two frames. Okay, this factor relates rest frame and the second frame. Okay, now we come towards solution. First we come towards part A of the solution. Okay, here delta t is equal to delta t naught over 1 minus u square over c square, equation number 1. What is this equation? This is thus tool number 1. We again go to tool number 1. Okay, this is tool number 1. Okay, delta t is equal to delta t naught over 1 minus u square over c square. Okay, so what we have done? We have done nothing. We have just used tool number 1 and given equation number 1 name to that tool. Okay, so here tool number 1 has taken the form of equation number 1, delta t equal to delta t naught over 1 minus u square over c square. Here delta t naught is given in the problem, which is 100 nanosecond, and we know that nano is equal to 10 raised to the power minus 9, micro is equal to 10 raised to the power minus 6, milli is equal to 10 raised to the power minus 3, femto is equal to 10 raised to the power minus 15, and similar various other. Okay, anyhow, so dear students, this 10 can be written as 10 raised to the power 2. Okay, 2 multiples of 10. So 100 is 10 raised to the power plus 2, and it is being multiplied with 10 raised to the power minus 9. Okay, so from minus 9 plus 2 will be subtracted and remaining minus 7 will be left. Okay, so delta t naught is equal to 10 raised to the power minus second. Okay, both are capital terms, whether we call it 100 nanosecond or 10 raised to the power minus 7 second. Okay, moreover, u is given as 0.960 c. Okay, and we know that c, speed of light, its exact value is 2.998 meter per into 10 raised to the power 8 meter per second, but we usually take its approximate value, that is 3.00 into 10 raised to the power 8 meter per second. Okay, putting in equation number 1 we get delta t is equal to 10 raised to the power minus second over 1 minus 0.960 c whole square over c square. Okay, here dear students, c square will be cancelled out with the c square and we will be left, this expression will alternatively become equal to 10 raised to the power minus 7 second over 1 minus 0.960 square. This expression will alternatively become equal to 10 raised to the power minus 7 second divided by under root 1 minus 0.9216. Okay, 0.9216 is when we multiply 0.960 with 0.960. Okay, that is square of 0.960 is equal to 0.9216. Okay, this expression alternatively becomes equal to 10 raised to the power minus 7 second divided by under root 0.0784. Okay, this alternatively becomes equal to 10 raised to the power minus 7 second divided by 0.27. Okay, dear students, here we can directly calculate its value from calculator, manual calculator, calculator given in the computer. Okay, yes. Other thing is that there are yet other means to find out this value, but it is quite okay. In the presence of calculator, we do not need to go to alternate method. Okay, so this alternatively becomes equal to 3.571 into 10 raised to the power minus 7 second. Dear students, to this extent our answer or our solution is quite okay, but actually 10 raised to the power minus 7 is not a specific quantity. Okay, because specific quantity is 10 raised to the power minus 3 or 10 raised to the power minus 6 or 10 raised to the power minus 9 or 10 raised to the power minus 12 or 10 raised to the power minus 15 or 10 raised to the power minus 18 or 10 raised to the power minus 21 or 10 raised to the power minus 24. Okay, that is multiples of 1000. 1000 is equal to 10 raised to the power 3. Okay, so we again try to convert it in a nanosecond. So okay, so when we will convert it into 10 raised to the power minus 9, then in place of 3.571 it will become 357.1. Okay, so this has alternatively become equal to 357.1 into 10 raised to the power minus 9 second, and we know that 10 raised to the power minus 9 is called nano. So here we can write it as 357.1 nanosecond. Okay, our part A of solution has been solved successfully. Okay, now we come towards part B. Dear students, we used equation in earlier classes, S equal to Vt. Okay, where S is the distance, V is the speed, V is the velocity and T is the time. Okay, so here in place of S we have used D, and in place of T we have used delta T. Okay, delta always represents change. Okay, anyhow, value of V is given in the problem, which is equal to 0.960 C, while we have calculated delta T in part A. Okay, in part A 357.1 nanosecond. Okay, this is delta T. Okay, delta T. So here D is equal to V is given in the statement, and delta t we have calculated in part A, so we have put both these values. Okay, in the next step we have used the value of C, okay, which is 2.998 into 10 raised to the power 8 meter per second into in place of delta t we have used the value which we have calculated in part A of this problem. Okay, in the next step this expression has been simplified. How simplified? Dear students, 1 second is in the numerator and 1 is in the denominator. These 2 seconds will be cancelled out and our answer will be only in meter. Okay. Moreover, dear students, we can see that 1 is 10 raised to the power plus 8 and 1 is 10 raised to the power minus 9. Okay, so minus 9 is one place greater than 10 raised to the power 8. So 10 raised to the power minus 1 will prevail. Okay, 10 raised to the power plus 10 and 10 raised to the power minus 9. Out of these two multiplying factors, 10 raised to the power minus 1 will remain in the shape of 10 raised to the power minus 1, and hence D will alternatively become equal to 1027.76 into 10 raised to the power minus 1 meter, and this will alternatively become equal to 102.776 meter. Okay, our part B has been solved. Now we come towards part C. Okay, D naught. D naught is equal to V delta T naught. Okay. V is given in the statement 0.960C and delta T naught is also given in the statement 100 nanosecond. Okay. Both are given in the statement. So 0.960 into 2.998 into 10 raised to the power 8 meter per second into 100 into 10 to power minus 9 second. Okay, in the next step we are going to just simplify this expression. Second is the numerator will be cancelled out with the second in the denominator and we will be left with the unit only meter. Okay. Moreover, dear students, here 10 raised to the power plus 8 and this 100 can be written as 10 raised to the power plus 2. So plus 2 and plus 8 will become 10 raised to the power plus 10, while this is 10 raised to the power minus 9. Okay. So out of these two multiplying factors, 10 raised to the power 10 will prevail, but it will reduce from 10 raised to the power 10 to 10 raised to the power plus 1. Okay, quite school level physics. Okay, so D naught will become equal to 2.87808 into 10. That is to say 10 raised to the power 1 meter. Okay, because 10 raised to the power 8 and 10 raised to the power 2 will become 10 raised to the power 10, and out of these this 10 raised to the power 10, 10 raised to the power minus 9 will be evaluated and only 10 raised to the power plus 1 will be left, and hence D naught alternatively and finally becomes equal to 28.7808 meter. And this is the end of our module. Till next, this is the end of our video. Till next video, Allah Hafiz.